Alright, so in Nura Studios on the wall, Kid 10 decided to post that before I was creating my Create a One Piece kind of series, I was making a data persistence type of model, and he was asking me how do I use data number save in data persistence. So I wanted to go ahead and make this video about showing you the differences between data store and data persistence and what that is. If you guys don't recognize this picture, this is from the initial data persistence show, like when it first came out. The game was called Cow Clicker. You got to just sit there and click on the cow and get it. Alright, so I'm going to go ahead and jump right in. So, data persistence is basically a method of saving data for games so that it can be loaded when the player joins the game again. Data stores were recently introduced, and they're better than quote-unquote data persistence, and they're recommended for new players and methods. So, data persistence has many uses just like data store. Data persistence, you mainly see them when people are using it in RPGs to say level your experience, your gold. When you're building games, this is one thing that data persistence can do that data store can't. Data persistence can actually save a model. This is shown in a Roblox building. If you create your little building, you can save your game, leave and rejoin, and it's back. That's all done using data persistence. You can use, say, in checkpoints for obstacle courses and obbies. You hit a block and your value goes up and it saves. Or you can go to tycoons and you can save your money and whatnot. So there's some restrictions to using it. It's server side only. You have to use it within a local script. Within a script, not a local script. If you don't know what that means, is a script runs server side per server, and a local script runs client side. I've done a video on it in the past, so you can check that out. It's only per user per place. So it's specific to one person per place. You can't share data between two people. That's one thing. And then you can't save it to, like, say you want to switch from one place to another. Like you want to make like a universe kind of thing using data persistence. You hit like X level, and you go through a door, and it teleports you to another game. Since data persistence is place only, all your data stays in the place you were at, and you'll have no stats at the new game. Now, there's a limit on data persistence and how much it can store. If it passes that limit, then you can't store any more data. So, booleans and numbers cost one data complexity unit. Data complexity unit is basically how much data the object is taking up. So strings cost their length divided by 100. Let's say you had a one length string, which is one letter. You divide that by 100, and that's what you get. You have 1/100th of a data complexity. Instances cost their data cost in complexity units. Saving the default value of 0 or false for booleans or blank for strings in nil instance removes the key from the data complexity count. So basically, if you set it to nil or 0 or false or whatever you want to do, you basically remove the data stored, like what it's gonna charge you, quote unquote. But when you're using the save boolean, save string, save number instance, that kind of thing, if the player goes over the limit, which is 45,000 units, defined by the data complexity unit, the function gives an error that your value is not saved, and any value that you have previously is deleted. So that can turn out to be quite an issue if you want to create a big game. It can turn out to be a big issue. Note the fact that people can lose their data. So basically, how it works is when a player enters the game, Roblox calls a local data on your player. Now you have to wait for your data to be ready, which is called the data ready property inside of your player. It also helps if you use a wait for data ready, so you don't try loading values that are considered nil and you cause an error in your game. However, when the data is ready, you can save it using the save boolean, string number, save instance, all that kind of thing. But you have to save it per player. That's where it loops back to the whole only per user per place. So that's how it happens. Some things to be aware of is you cannot save or load data of a player immediately after players join your place. You have to wait till your data is ready, basically. If you try to join your game and then say, as soon as they join the game, as soon as their character spawns and loads in, a value for, say, place visits goes up. You can't do that because you have to wait for your value to be ready and your data to be loaded into the game so you can edit it. So there's some controversies using the data persistence. There's multiple occurrences where this method intertwined with player removing event will take care of the issue of it not functioning correctly. Now what that means is basically you save it when your player leaves the game. So that's one thing that you can do with data persistence that you can work really well with compared to data stores. Now I'm not going to get into the XML and JSON portions of data persistence. That can wait for another video. So I'm going to go ahead and start explaining about data store. So this picture is a reference to one of the first free places that was created showing an example of data store and how it can be used. Basically what it does is it changes colors of the brick, I believe it was, whenever you hit the buttons, which are the blue and red ones down here. So data store is a new API called data store, obviously, which is quote unquote more powerful and robust than the old data persistence system. You can create arbitrary data which persists even when games are not running and can be accessed by all instances of a place in your game universe. So basically you can use a data store to instance variables and data across servers. So say, like I was using my previous example of, you hit X level, you go through a door, you go to a new game. With a data persistence, you would lose all your stats in the new game. However, with a data store, so long as it's in a universe setup, your data will retain across servers. So, some differences between some advantages over data persistence is data stores have virtually no data limit, whereas data persistence, as I said before, has 45,000 data units per player. Data stores are accessible from any place at any time in the same universe. If a call from the data store API returns, the data is confirmed to be saved, so no data loss when the server crashes. So basically, if you have a save, whereas in data persistence, if you want to save your game or something and your game crashes, you have a chance of losing your data. Whereas data store goes over with the data store API, and it basically ensures that you don't lose your data. You can save arbitrary Lua tables besides strings, booleans, and numbers. So basically, you can just save int values, integers. Instances can't be saved directly though. We can also test the data stores within a local test server, whereas with data persistence, in order to test it, you have to go into the game itself. So a data store is essentially a long list. Each entry in this list has two parts, a key and a value, as you can see in this picture here. So your keys must be a string. Your key is basically how you save the value, how you save, like what you're calling it, basically what you're saving it as. So say your user is, you have user, and then this would be your player ID. So whenever you try to load user 3814, you get the value of 400. Whereas if you try to load user 261, you get 440. So it's pretty easy to get a concept on. Now, just like data persistence, data storage can only be called from a server-side script, a regular old script. You can't use a local script for this, otherwise it won't work. Now, there's multiple methods for it. You have the get async, set async, update async, and commit. And these are all just different examples of how you use it. So I'm going to skip over that. Now, there's different types of data stores. You have a regular data store. You have your ordered data store. An ordered data store is a special type of data store, which the value must be an integer. That's like the basic definition of it. Alright, so then you have your names and scopes. Data stores provide a way to create a good organization for all your data stores. For instance, if you try to put per player data, per server data, and other informational data into one data store, things get messy. So that's why you organize it by namespaces and data store names, to make sure you can organize your data. So basically that's saying if you want to create different types of data store that holds different portions of value, like say data store X holds one thing, the data store Z holds another. You can do that without having to run them in the same scripts. So a sample scope could be global. You can also have it. This is also the default argument for your scope. Global. then the function will work into the global namespace. So there's a request limit on data store. So data store sends information to Roblox itself to save online in certain amounts of requests. So each request has a different limit on how much data it can send. So these are your different methods, and these are the limits. So 60 plus number of players times 10. So basically it's saying if you have one player in the server, you have 60 plus 10, so 70 requests allowed per minute. Say you had 20. 60 plus 200, so 260, that kind of concept. It's that kind of concept all the way through. So let's say we have a data store we want to regularly call get async in a game with 2 players. Looking at the chart, we see that we can make 80 requests per minute. You get this from the 60 plus 2 times 10. If you go over any of these rates, your requests can be throttled, meaning they will take longer to execute. This will continue until the number of requests is less than the request rate. This can create a problem with your game if you are relying on quick requests to get the most up-to-date information from your data store. With this in mind, it's very important to manage the rates at which you use data store functions. It's also advised that you disconnect on update events when you no longer need to free them up. The number of times it can be fired without getting throttled. Note that each type of operations gets throttled separately. If you are making too many get methods will be throttled, but the other types requests such as sets will remain unthrottled as long as they're above their respected limits. So it's basically saying if you go over your data limit, like the amount of requests you can make per minute, then what it does is it'll pause, it'll stack up requests and continue to update them up to the server. So say you can only update 80 requests per minute with 2 players in your server, but you have like 200 requests going in. It'll stack up, saying if you have 200 requests set to go, it'll let 80 in at a time. So it'll let 80 in now, then you'll be down to 120, then it'll let 80 more in next time, and continue until it's back to 0, or the lowest it can get. There is a data limit on some of the numbers and characters. So the data limit per value, you can't save anything with data side which is more than 64 kilobytes, which is like 2 to the 16th string characters. Tables are saved in JSON, which means that they're encoded in JSON string. Should not exceed length of 2 to the 16th power characters. Numbers and booleans will never exceed this length. For strings, you can call the function with a string.len. String.len is something I'm going to do in another video in the future, so I'm going to skip over this for now. If the return's less than 2 to the 16th power, you can be sure that this key can save. Basically, it's saying if it's higher than that, it won't save. So you can have up to 50 characters in a key, 50 in a name, and 50 in a scope. Now, occasionally see an error occur saying request rejected. When performing a data store operation, this usually means that the Roblox backend has sudden increase in requests and needs a bit of time to compensate. That's kind of what I explained earlier with the whole requests per minute and stacking up. Now, as I said earlier, with like data persistence, you can't save instances with data store or models. So that's another difference. You can test, however, data stores within a local server, whereas you can't with a data persistence. And it's sometimes desirable for you to save your game when you leave, but it's not always a great case because it'll stop say the last person is trying to update data. You're going to lose all your data because the server's going to shut down. So I hope this explains some of the issues people are having with data stores. I wanted to get this through so I can make another video on data stores and data persistence. So I'm running out of time, so I'm going to go ahead and end this video here. I hope you guys enjoyed. If you like this video and want to learn more, subscribe to my channel, leave a comment with suggestions, and check my videos. So thank you for watching.